All right, let's go back to our uh, position time graph for Frodo's motion, and let's take a look at finding average velocity from here and what it tells us about uh, Frodo's motion. If we look at his average velocity from position D to position E, we would have to find his displacement over the time interval, which would be delta x over t. So if you see here, my delta x and delta t, and I draw on the dotted line here indicating the connection from point D to point E. Now if you notice in this formula and in this triangle, you should see something very familiar. What I'm finding is the rise from point D to E over the run from point D to E, which is just the slope of the line connecting D to E. So if I find the slope of the line connecting D to E, what I'm finding is the average velocity between those two events, or those two intervals. Now let's look at another one. Let's say I wanted to find the average from D to F. We'll go green with this one. I need to find the displacement over the time. So I would draw in from D to F my time interval, my delta t, and my displacement is my delta x, and I'm going to connect the two with a triangle. So my rise in this case is the same. Now I didn't solve it here. Let's solve it here. We'll go back to black. What is V average? Delta x from D to E is 10. Delta t is from 7 to 10, which is 3.3 meters per second. Okay, so from D to F, delta x is the same because from E to F he's not moving. So 10 meters over. Now an extra 2 seconds has gone by. So my average velocity is 2 meters per second. So now let's take a look at the graph and take a look at these values. You'll notice the average velocity from D to E is greater than the average velocity from D to F. Well, that makes sense because from D to E he's moving the whole time, and once from E to F he's sitting still or in the same place. So if you include the resting time as part of finding the average velocity, you would expect it to go down. The time interval increases where the position doesn't change. So you can also notice that the slope of this line is steeper than the slope of this line. Therefore, steeper slope indicates higher average velocity. All right, let's take a look at another one. Let's go from, how about from E to F? From E to F, my average velocity is change in position over time. But from E to F, I'm at position 5. In position 5, my change in position is 0 over the 2 seconds. So 0 meters per second is a horizontal line, which is slope of 0. Remember, horizontal lines have a slope of 0, not vertical lines. Vertical lines have an undetermined slope, undefined. All right, one more. Let's go back to blue. How about from F to G? What's his average velocity? So change in position over change in time. So from F to G, my change in time, my change in position, connect the two. Now I go negative 5. From positive 5 to 0, 0 minus 5 is negative 5 meters over 4 seconds. So I get 1.2 meters per second, but negative. So now, negative indicates downward slope. So negative average velocity. Oops. V average. Okay, so hopefully you're getting a feel for how we can use the position time graph and the slope of the line connecting two events to find the average velocity. And this is one of the key concepts, so make sure you really understand this and take the time to jot this down. So if I have a position time graph and I connect any two events or any 2 points on that line, and I find the rise and the run, I am finding the average velocity between those 2 points, which is the slope of the line that connects the two. So maybe pause a sec and really jot this down and make sure you recognize this. Okay, let's do a couple practice problems. So take a second and draw a new position time graph here. This is a slightly different one for the couple problems I'm going to give you. This is another, let's just say this is still Frodo, getting chased through a different part of the mines of Moria. Alright, first thing I want you to figure out, during what time interval does Frodo have the greatest positive velocity average and the greatest negative velocity average? So pause the video, sketch down the position time graph, and I will show you the answers in a second. Okay, so if you look at this graph from C to D, which is the steepest positive slope, which has a value of 3 meters per second. It's a rise of 12 and a run of 4. That's the greatest positive. And from E to F, which has a rise of negative 12 and a run, negative 10, excuse me, and a rise of, or a run of 4. That's our greatest negative slope. One more question. So how does the average velocity between A and B compare to the average velocity between G and H? And then lastly, how does the average velocity between A and D compare to the average velocity between C and E? So pause that and work on that for a sec. Okay, your answers are from A to B, so the line A to B and G to H, if you solve it, you should get 1.5 meters per second, so they are the same. Notice they're the same upward positive slope, same angle. And from A to D, something like yay, and from C to E, you should get A to D is 1.9, C to E at 1.5. Notice this appears slightly steeper than this by not much, but it's definitely greater.